So let's talk a little bit about how we express a probability statement using mathematical notation. I'm bringing this up because in later sections in this chapter, I'll be using this quite a bit. So I want to make sure you understand what this means. So the basic idea is we want to say the probability that something occurs is some number. That number, of course, will be between 0 and 1, 0 meaning it's not going to occur, 1 meaning it will certainly occur. So that is going to be some number, we'll call it little p. That'll be a percentage, 25%, 76%, whatever. And we write capital P, parentheses, description of the event equals whatever the number is. So we read this as the probability of the event is little p, where there'll be more specifics in there. So unlike the way you've probably used parentheses in algebra, in this case, the parentheses are not to be read as something multiplied. If you've ever taken pre-calculus, you might have seen function notation, and this is similar to that. That's where this comes from. So let's look at a few examples. So kind of with the example we left off with last time, we were looking at the probability that we roll something bigger than a 15 on a 20-sided die. So using the theoretical probability, this statement says probability that my roll is bigger than 15 is 25%. Here's another example with customers. So this 10% may come from a survey that you run, so you get some data to make this assessment. And you might say, the probability that I will have more than 100 new customers after offering a new service or product is 10%. If we're talking about the example where we were working with a felon who's recently been released and we're helping them reintegrate, then we might say the probability that the felon will commit, the former felon, that our client, let's say it that way, the probability that our client will commit more than 0 crimes, so at least one further crime, is 46%. And that may be based on data. That's called recidivism, when somebody who finishes their sentence commits another crime. And so you may have, this may be an experimental probability based on, say, records of those who finish their sentences for all the same crime. And here's another one. This may also be an experimental probability based on data. Remember, this is the case where you're only brushing once a day instead of twice. And this statement says the probability that the number of cavities you have will be greater than 0 is 12.73%. Number of cavities greater than 0 can be thought of, I will get a cavity, right? So it's non-zero, can't have negative cavities, so it's 1, you're allowing it to be more. Right? So that's how we read these statements, and that's how we use this notation. In the next section, we're going to talk about probability distributions, which will tie us back to data distributions from chapter 2.